Good afternoon, class. Here's chapter 3, derivatives, section 3.4, the product and quotient rule. And we're going to continue finishing it off with part 2. H of x is square root of x times e to the power of x. To differentiate that, first and foremost, we change square root of x such that the power rule can be used. We change it to x to the power of 1/2. Then we put a raised dot in between. We call this the f function. We call this the g function. And now we can use the product. So f prime g plus g prime f is the shorthand notation. F prime is 1/2 x to the power of 1/2 minus 1 makes it negative 1/2 times g, or e to the power of x, plus g prime, the derivative of e to the power of x is itself, e to the power of x, times the first function fx to the power of 1/2. This is the end of calculus step. Now we have several algebraic steps. Number 1, x to the power of negative 1/2 goes down, becomes x to the power of positive 1/2. We are using negative exponential rules. Okay, look at these two. Okay, so if it's at top, you can take it to the bottom and make it positive. And since x to the power of 1/2 is square root of x, we change it to square root of x. We do the same thing to this one. We want to put this together, and if we multiply this and divide this by the denominator, we can take a common denominator and factor them out. Notice in the numerator we have this product, e to the power of x squared of x, 2 squared of x. So what we have is really e to the power of x times 2x. That's what we have in the numerator. So this portion is in common. This is the same as e to the power of x over 2 square root of x. And we rewrite it in this format so we can clearly see this is in common. If you take it out, this gives you 1, this gives you 2x. And the reason it's important to be able to do so later on when we look at application of differentiation, we need to be able to write it in this fashion, find when this differentiation function is 0 or it does not exist. Y equals e to the power of x over 1 plus x. We are going to write it as f over x, and we are going to use the quotient rule on that. So we need f prime, which is e to the power of x itself, times g, or the bottom is 1 plus x, minus g prime. 1 plus x results in 1. So minus 1 times the top, which is e to the power of x. Now, the bottom, 1 plus x, you put it in a parenthesis and square it. All we need to do is to simplify the numerator by distributing, and we get e to the power of x here, e to the power of x times x, minus e to the power of x, and these two cancel each other. And we put the x in front of e to the power of x, and that is our final answer. Differentiate y equals 1 plus sine x over x plus cosine x, and we are going to write this as f over g, and again we are going to use the quotient rule. So I would write the quotient rule from memory, okay? And I would follow that instead of writing d dx of this and d dx of that. It's a lot easier. Write the formula from your memory. You should memorize it. And then apply that. So f prime, the top gives me cosine x times the bottom, x plus cosine x, minus g prime, the bottom gives me 1. Cosine gives me negative sine x. The derivative of cosine x is negative sine x. So 1 minus sine x. And then I need f, the top, which is 1 plus sine x. Finally, I write the bottom just the way it is, x plus cosine x, inside the parentheses and square it. Again, done with calculus, we are going to distribute and figure out what we get. So this is easy. The product of these two is x cosine x. The product of these two is cosine squared. What I want to mention is this. A minus b times a plus b. The answer is a squared minus b squared, which means 1 minus sine squared. So again, distribution gives us x cosine squared. The product of these two parentheses results in 1 minus sine squared. I remind you of Pythagorean identities that you're supposed to know from trigonometry. Sine squared plus cosine squared equals 1. If you divide both sides by cosine squared, you get tan squared plus 1 is secant squared. If you divide both sides by sine squared, you get 1 plus cotangent squared equals cosecant squared. Because sine squared and cosine squared, they add up to 1, you should know that 1 minus cosine squared is sine squared, 1 minus sine squared is cosine squared, so this will be replaced with cosine squared. Cosine squared, negative cosine squared cancel each other. And the numerator is left with x cosine x. The denominator remains unchanged. G of t is t minus square root of t over t to the power of 1/3. The reason I'm asking about quotient rule is to mention a very important concept, and that is if you need to use the quotient rule and you try to avoid it, normally it makes it more difficult. If you don't have to use the quotient rule and use it, normally one makes a mistake. So why is it that I'm asking this question? Because if you make up two fractions, you won't need to use the quotient rule. So t divided by t to the power of 1/3 minus square root of t is t to the power of 1/2 over t to the power of 1/3. When the denominator consists of one algebraic expression or a monomial, you make up as many fractions as you need. Now, using the quotient rule for exponents, this is t to the power of 1, and it becomes t to the power of 1 minus 2/3. And the second one is t to the power of 1/2 minus 1/3. So 1 minus 1/3 results in 2/3. 1/2 minus 1/3 results in 1/6. And therefore, we can use the power rule. So this is 2/3, t to the power of 2/3 minus 1, which makes it negative 1/3 minus 1/6, t to the power of 1/6 minus 1, which makes it minus 5/6. So again, this one is 2/3 minus 1. And this one is 1/6 minus 1. Now, again, back to the negative exponential rules. If you have a negative exponent at top, take it down. So take this down and make it positive 1/3. The same thing, take this one down and make it positive 5/6. Whether you keep it as t to the power of 1/3 or cube root of 3, it really makes not much of a difference, because if you go back to the original question, both were given to you, so you choose both types. Prove that the derivative of tan x equals secant squared. So y or f of x equals tan x, and we want to prove that. So the derivative of sine is cosine. This does take a lot of algebra, trigonometry, and geometry to prove. We do it in calculus 1, and then from there on becomes easy. The derivative of cosine is minus sine. The rest of them use the quotient rule. In this case, says the derivative of tan x is secant squared. So let's prove that. How do we do that? Recall tan x is sine x over cosine x from trigonometry. So let me remind you of some of the formulas we have seen. Tan x is sine x over cosine x, or 1 over cotangent x. Cotangent x is cosine x over sine x, or 1 over tan x. Secant x is 1 over cosine x, and cosecant x is 1 over sine x. These four are known as reciprocal identities. And now I can use the quotient rule by calling this sine x the f function, cosine x the g function, and use the quotient rule for differentiation. So f prime g minus g prime f over g squared. The derivative of the top is cosine x. So times g, which is cosine x itself, minus the derivative of the bottom. The derivative of a cosine is negative sine x, times f, the top is sine x, and you just write the bottom squared. So what do we have? Cosine squared plus sine squared. As you know, the sum of sine squared and cosine squared in any order is 1. If 1 over cosine x equal to secant x, 1 over cosine squared must be equal to secant squared x. Therefore, d dx of tan x is secant squared, or the derivative of tangent is secant squared x. So we proved that. What about secant x? The derivative of secant x, secant, is equal to secant x tan x. Let's prove that. We are going to use the fact that secant x is 1 over cosine x, 1 over cosine x. And we're going to use the quotient rule of differentiation. Therefore, I'm going to call this f over g. In other words, according to that, f of x is 1, g of x is cosine x. So we're going to need f prime, any number results in 0 when you differentiate, times g, which is cosine x, minus g prime, minus the derivative of cosine is negative sine, times f times 1. And you just write the bottom, square it, cosine squared. So this goes to 0, this goes to plus sine x. We can rewrite this, these are the stuff we've done in trigonometry, as 1 over cosine times sine x over cosine. Why do we do that? because 1 over cosine is secant x, so we replace it. Sine over cosine is tan x, we replace it. And we just proved d dx of secant x is secant x tan x. So I highly recommend you try cotangent x and cosecant x. Prove the derivative of cotangent is negative cosecant squared x. The derivative of cosecant x is minus cosecant x, cotangent x, for practice. Find an equation of a tangent line to the graph of the function y equals x over 2x minus 7. To find the equation of a tangent line, you need two things. You need a pair x comma y is given. You also need to find the slope, which goes through the process of differentiation. So we are going to differentiate this by calling this f, this one g, and using the quotient rule. So y prime is f prime. The derivative of the top is 1 times the bottom, 2x minus 7, minus the derivative of the bottom, g prime is 2 times the top x, and just put the bottom in a parenthesis and square it. Again, I'm going to remind you, if I'm differentiating this, first I'm going to write the formula for me from the memory and just follow that. It goes a lot faster than any other method, I promise you. So all we have to do is simplify the numerator by distributing. We get 2x minus 7 minus 2x. 2x and minus 2x cancel each other. And this is y prime, but this is not the slope. When we evaluate it at the x coordinate, number 3, we get this slope. So if I plug in number 3 here, it results in minus 7 over 2x, 2 times minus 3, 2 times 3. Why did I put negative 3? 2 times 3 is 6. Minus 7 is negative 1. Squared, you get positive 1. And this ratio is negative 7. Now we use y minus y1 equals m times x minus x of 1, which means y minus negative 3 or plus 3 is m or minus 7, x minus 3. We are going to distribute, and we get minus 7x plus 21. We are going to subtract 3, and it results in y equals minus 7x plus 18. That is the tangent line. And if you plug in and it works, it just says that this process was right. We want to differentiate this, and on purpose, I've used this with a different variable. Normally, we use x as the independent variable, in some cases t or even theta. We're going to use something else. I want to mention that it doesn't have to be x. Okay, so the differentiation works in the same manner. First and foremost, we're going to call this f over g, and we use the quotient rule. So I need f prime. I'm using this formula, which is 9 times g, minus I need g prime, so that means I need 5 times f, which is 9m minus 7. And then I put the bottom and square it. All we have to do is simplify the numerator by distributing 45m plus 36 minus 45m plus 35. These two cancel each other. These two add up to 71. So we want to find an equation of a tangent line to the graph of the function y equals e to the power of x cosine x at 0, 1. We need two things, a pair which is given and the slope. Therefore, we are going to put a raised dot in between and use the product rule. I'm going to call this the f function, this one the g function, and so we need f prime, which is e to the power of x, times g, which is cosine x, plus g prime, the derivative of cosine is negative sine x, times f, which is e to the power of x. We factor out e to the power of x. And to find the slope, we have to evaluate it as at the x coordinate 0, which makes it e to the power of 0 times cosine of 0 plus sine of 0. E to the power of 0 is 1, cosine of 0 is 1, sine of 0 is 0, and it makes it 1. So instead of using y minus y1 equals m times x minus x of 1, which is the point slope, because the y-intercept is given and b equals 1, we use y equals mx plus b. It so happened both m as well as b are the same value, 1. It's not the case always. It just happened to be in this case. Differentiate y equals 1 minus secant x over tan x. We are going to write this as f over g and use the quotient rule. So we need f prime, the derivative of the top, 1 gives you 0, minus secant, the derivative is secant x tan x, times a g, the bottom is tan x, minus g prime, the derivative of tan x is secant squared, so minus secant squared, times f, just times the top, 1 minus secant x, over g squared, just write the bottom and square it, tan squared x. Again, done with calculus step, all we have to do, simplify using algebraic techniques as well as the trigonometric technique. So this becomes minus secant x tan squared. This becomes minus secant squared x plus secant cubed. In the numerator, they all involve secant x, so we take the common factor of secant x out. This gives us minus tan squared x minus secant x plus secant squared x. We went over trigonometric identities. One of them was 1 plus tan squared equals secant squared, or tan squared plus 1 is secant squared. If I move the tan squared to the right, then secant squared minus tan squared, that means secant squared minus tan squared is 1. So this one and this one combine to give us number 1. And the final answer is secant x times 1 minus secant x over tan squared x.